This is Mr. Ward. I'm going to do a key for Do Now 18.1, and let's go ahead and get started. So I'm going to first deal with this proof. So I've given you some hints. I'll come back to that. So we're supposed to prove that triangle XAY is congruent to triangle ZAY. And we're given some information. WX and WZ are congruent, so we'll just go ahead and label that. WX and WZ are congruent. And we're also given XY and ZY are congruent, so let's label that too. So XY and ZY are congruent. Cool. So we know that. Now, we're supposed to prove that this triangle is congruent to this triangle. And here's what we need. So we're going to have to prove another pair of triangles. That's the hint. Congruent first. That's what makes this a detour problem. We're going to have to go on a detour of proving another set of triangles in order to get the information that we need to prove these triangles are congruent. Okay, so let's look at what we have. So we can very easily prove WXY and WZY are congruent. After the givens, we just need to say that WY is congruent to WY by reflexive. Okay, and once we've done that, let's go and label that detail. So there we go. WY is itself. Once we have that, now we can prove that triangle WXY, so triangle WXY is congruent to triangle WZY by side, side, side. Okay, now that we have side, 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 we've proven those two triangles are congruent, we can start doing some Kappa-Kadika action. Okay, so we can state that angle XYA and ZYA are congruent by Kappa-Kadika. So angle XYA is congruent to angle ZYA. Okay? Corresponding parts of congruent triangles are congruent. Now, I didn't go all the way to W. I could have either way, but I did want to kind of emphasize that my next move after I have identified those as congruent. Here we go. This is congruent here and to this here. Once I've identified that, now I'm going to identify AY as congruent to itself. So let's do that. Let's pick a color. I'm going to pick light blue. Okay, so I'm now going to prove that AY is itself, okay, by reflexive. So AY is congruent to AY by reflexive. And once I've done that, I can prove that triangles XAY and ZAY are congruent by side, angle, side. So triangle XAY is congruent to triangle ZAY by side, angle, side postulate. That's what you needed. So first we had to go on a detour to prove these two side triangles are congruent, and that gave us the information to prove that XAY and ZAY were congruent. Now let's take a look at the next one. So in this next one, we are supposed to prove that AD is an altitude. Okay, if it's an altitude, then that means it is perpendicular to BC. So it would be useful to figure out some way to prove that these are 90-degree angles. Okay, so here's the information we've been given. We've been given AB and AC are congruent. Okay, so let's label AB and AC. So that's congruent with that. And we've also been told that BD is congruent to CD. So BD and CD are congruent, so let's label that as well. So we know that this is congruent to this, and that's useful too. Now, in order to prove that AD is an altitude, well, if we could prove that these two angles were congruent, well, they happen to be supplementary as well. If they were congruent and supplementary, then that means they would have to both be the same thing and add up to 180 degrees, which would mean they would have to be each half of 180 degrees. So by algebra, we could prove that these would be 90 degrees each if they're congruent. So let's see if we can prove these angles are congruent. If we can prove that these triangles, ACD and ABD, are congruent, then we can prove by Kappa-Conica that angle ADC and ADB are also congruent. So let's start going at it. And I think we'll be able to do that fairly easily. Givens, after the givens, then I would say the next thing to do is prove that state that AD is congruent to AD by reflexive. Reflexive sure gets around. So now we can say that triangle, I'll just say ADB is congruent to triangle ADC by side, 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 because we got three sides that are congruent here. Okay, side, 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 and side, side, side. Okay, now once we have that information, we can argue that angle ADB is congruent to angle ADC by Kappa-Conica. Okay, so let's label those angles that are congruent. Okay, I'll pick a dark blue for that. Okay, like that. And then we can then say that ADB angles ADB and ADC are right angles because they are both supplemental and congruent. So so we can say 2x equals 180. So x equals 90 by algebra. Okay. Now that we've proven that that is true, then we can say that AD is an altitude by definition of altitude. Okay, and let's go ahead and make these clearly right angles like that. Okay, one last proof for this do now. Now here, we've been told given an isosceles triangle with the median to the base. That's what we've been given. We are supposed to prove that the median is the perpendicular bisector of the base. So there's no diagram. So what do we do? Well, what we do is we draw the information that's been given to us. I'm going to erase that because it's getting in my way. But we're going to draw the information that's been given to us, which is labeled the given. Sometimes it'll be labeled the given. Sometimes it'll simply be a statement. So start by drawing it on paper. Then take a look at the hint in number 2 as well, which is the hint that how many degrees, what would the measure of two angles be if they're both supplementary and also congruent? In other words, they're congruent and adjacent. The theorem you'll be learning about, I believe, in section 4.3. So let's draw this triangle. So we're going to start by making an isosceles triangle. These two sides are congruent. And then here's going to be the base. And we're going to draw a median to the base. So let's use this. So this is going to be a median. And by making a median, what that does is it makes this and this congruent. All right, so that's all stuff that we've been given. Okay, we're told this is an isosceles triangle. So if we want to prove that it is the perpendicular bisector of the base, we don't have to prove it's a bisector. We just have to prove it's perpendicular because it's already stated that it's a bisector by definition of a median. So we have to prove that these two angles are right. And we just did that in the last one. So let's go ahead and do the thing. So we know that we have our givens, and we know that triangle, I'm going to give these letters, okay? So I'm going to call that A, B, C, and D, okay? Make that more of a proper D. So we'll call this triangle, this one on the left, ADC is congruent, oops, that's lowercase c, is congruent to triangle ABC by side, 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 because we already have three sides that are congruent. Actually, I do need to state that AC is congruent to AC by reflexive. That does need to be stated. Okay, but now we have the information to prove that ADC and ABC are congruent. Those triangles are congruent by side, side, side postulate. And once we've proven that, we can prove that angle ACD is congruent to angle ACB by kappa Kataka. Corresponding parts of congruent triangles are congruent. So let's identify that. I'll use a light blue. So this angle and this angle are congruent. Then we can go on to say that angle ACD and angle ACB are right angles because they are both sup and congruent. And half of 180 degrees is 90 degrees. Okay, and then we can say that AC is the perpendicular bisector. Actually, we might want to state, just note that AC bisects DB, that's a given by definition. Maybe we can add by definition of a median. Okay, and then AC is perpendicular to BD by definition of a perpendicular bisector is at a right angle to the segment that is divided into two congruent segments. Okay, and that's all you needed for that. I hope that helped.